Okay, I think we can start. You guys can ask questions in Russian. I'll translate them, and I can do both. But the reason I decided to give this talk in English is because we have people who speak English and do not speak Russian. But please don't hesitate if you want to ask a question, but you don't know how to do it in English. Ask it in Russian, and I'll translate it, and I'll try to be as helpful as I can. So, how many of you have written a web app? Okay. How many of you have written a web app in Lisp? Okay, not that many. 0 to be exact. So this talk will be kind of focused on writing those web apps in Lisp and what we have in the field for that. And since I think that every serious community need to have its own Lisp, we as Java developers, we're a pretty serious community, and we have our own Lisp, and it's called Clojure, right? How many people are familiar with Clojure? Great. How many people have written web apps in Clojure? Okay, so we have a couple of people who actually did written web apps in Lisp. That's great. For guys who do not know, Clojure, this talk is not going to be exactly about Clojure 101 or anything, but Clojure is a Lisp on JVM, right? So it has a great story of Java interoperability. So it has you can access anything you want from Java. You can use Java libraries and so forth. There's a lot. It has great concurrency primitives and lots of goodness. So we're going to be talking about the Clojure and the web arena, the web scene in the Clojure. But first, I'd like to thank this conference. I'd like to thank the organizers of this conference, and I think so far it's been pretty good. Yesterday we had the drinking party, and I think that kind of highlighted the conference for us. Another people I'd like to thank is the company that allowed me to be here. It's a very small family-based, family-organized consulting company. We do a lot of great stuff, including me doing Clojure, Scala, and so forth. So what are we going to talk about? We're going to look at some basics, Clojure syntax, and some basic primitives of Clojure Web. And not going too deep inside, but it'll give you at least an understanding of, I'm going to do a lot of live coding, so at least you're not going to be too lost in all these parentheses. We're going to look at the core async, which is something that Clojure stole from Go. Go is a language, and it basically allows you to, and we're going to talk about it, allows you to reason about concurrency sequentially, which is a little hard to figure out how to do it right away, but you'll see an example. It's actually not that difficult. And we're also going to look at something that's called OM. And OM is basically a Clojure way of looking at the Facebook React. It's called React.js, and they kind of threw all the MVC principles and very controversially introduced, in my view, a great product that Clojure kind of made it even better with adding certain parts of itself. And again, this talk is not for people who have experience in Clojure. However, this talk is for people who have some experience in Clojure, but if you do not have experience in Clojure, that's fine. We'll go in the first maybe 5-10 minutes, we'll go over the syntax, and if you have any questions at any time, Russian, English, Ukrainian, you can ask me, I'll translate it, and we'll, the idea is to kind of get you guys excited and not be afraid of Lisp, because Lisp is not something to be afraid of, and to ignite you with some passion, and maybe after this talk you can look into it and start doing something with Clojure, because it's a lot of fun. So first, let's go into Clojure syntax. That's pretty much it, right? You have some other stuff, of course, but that's the simple kind of gist of the Clojure syntax. We have a map, right? Clojure in any kind of Lisp has a mantra which says code is data, code as data, data is code, so there's no difference, right? So data structures would be a logical kind of fundamental part of the language, and that's the data structure that you have in pretty much any language, but adjust the syntax so you don't get confused with all the different parents. In other Lisps, like Common Lisp or other Lisps that people hate and don't like and very afraid of, everything has to do with one parenthesis, right? Clojure decided to give it a little more color, a little more shape to parentheses, and that's how you basically define those data structures. So we will play with them. So if this looks foreign to you, don't worry. It's not that difficult. So you have a map with keys and values. You have a vector. Think about it as an array list in Java. We have a set, hash set, right? And then you have a list. It's something like a linked list. One thing you can notice that Clojure is a dynamically typed language, so you can put, strings, numbers, some other quirky symbols, which we'll talk about it later. But basically, this is it. This is the Clojure for you. And of course, they're all immutable, right? That's one of the things that Clojure brings into the JVM party. JVM languages party. Everything, immutability is one of the biggest and most important things in Clojure. So if you, and we'll talk about it, we'll talk about how it's done a little bit, and but the benefits are obvious, right? If you work in a concurrency world, or you work with different CPUs or different machines or different anything, if your stuff is immutable, you have no problems. Because nothing can touch it, nothing can change it. You can create something, give it to somebody else, and you're not going to have any worry of these things changed on the way or being on that other end. So immutability is a big thing. Oh yeah, and this one little thing, Clojure is a functional language, right? So it's a function, and a function that takes two arguments and adds them together, right? Remember, in Lisp you have a method that we call in Java, or a function going first. So this is a function, right? Or in Java it's an operator, but let's say it's a function, and then you have arguments. That's the whole difference. Besides that, language is pretty much the same, right? You just need to kind of get used to the parentheses and get used to this kind of notation, and then you're good to go. So now let's, and again, we'll play with it live, so you're going to have a little more time to kind of to understand all the syntax. So now let's look at the usual aspects of Clojure Web, which there are plenty of different libraries, plenty of different tools that you can use in Clojure. In Clojure, the mantra is a little different from Java. In Java, and I have developed a lot in Java and heavily in Spring and Hibernate and all the usual suspects. But in Java, you tend to rely on the frameworks a lot, right? You have frameworks that suck you in. That's how your dependency injection context need to be done. That's how your JPA annotations needs to be done. And now, if you try to do something else, try to get out of it, you cannot, right? Because the framework actually specifies how you work, how you think, how you model your program, how you design your program. If the framework gets updated to the next version, well, you have to update your program if you want to continue and get new features. In Clojure, it's a little different. The mantra, the culture, right, is to rely on libraries. Right, so the usual suspects of Clojure Web are libraries, and pretty much everything in Clojure is a library. So we have something that's called Ring, which is basically think about HTTP protocol, just coded up. It has all the right statuses for you, it implements your servlet request response flow and so forth. You rarely need to work with it directly, but it is just something that lives underneath of your web application, right? But it's a library. You can use a different one. It's just one of the libraries that supports HTTP protocol. Another usual suspect, again, some people use a different routing library, but usual suspect is something that's called Composure. And if you guys ever looked at Ruby Sinatra or maybe Java Spark, that would be something very similar, and we'll look at it. It's a very, very kind of simple way to get your routes done. And the Clojure script is basically a Clojure code that's kind of put in through the Google Clojure with an S, Google Clojure compiler, and that produces a JavaScript. There are a lot of benefits going through Clojure compiler, or Google Clojure compiler, because it does a lot of optimizations. And again, this talk is not about JavaScript per se or a Google Clojure compiler, but Clojure script allows basically to use Clojure on front end, on back end. So you can use one language on both ends, because the usual paradigm is you do your Java on the back end, and then you do your JavaScript, or maybe you do some other some other language that compiles to JavaScript, but it's usually not Java. Clojure script allows you to write Clojure and get JavaScript transparently. And of course, there are many more, right? This is just 3 usual suspects that we're going to look at, and there are many more libraries that you can use. You can replace these libraries with other libraries, but these are the main 3 to start with. So if you get excited and want to start with something, there is a very good throughout articles and mostly on GitHub that you can go and search, and that's something to start with. Another thing that Clojure is since Clojure is a dynamic language. It has something that most of the dynamic languages have. It has REPL, right? REPL stands for read, evaluate, print, and loop, right? What does it mean? It means that it's basically like your terminal, right? You go to the terminal, you type, cd this directory, it goes to that directory. So it first reads that command, cd that directory, then it prints it, basically goes to that directory and prints it a prompt, and then evaluates it, prints it, and then loops. Basically, it's ready for you to print out a command. So that's what the REPL is. The cool thing that in a Clojure web space that you can do, you can have the same thing for your browser, right? Usually when you work with web apps, in the browser, what do you do in the browser? You do something like this, right? I don't know if it shows up, but you can look at down the bottom. That's your REPL in the browser. But again, this is alert, hey. This is a JavaScript browser, right? This is a JavaScript REPL. This is not a Clojure REPL or Java REPL. So again, it's a different language that you have to work with. The Clojure script allows you to, the Clojure script REPL allows you to still work in Clojure and have access to all the DOM in your browser, and we'll look at that as well. So enough talking. Let's break my live demo. So basically, first thing we'll do, we'll create an app, and again, line again is something similar to Maven, right? Or something similar to SBT if you work in Scala. Basically, it's a build tool, but it's a lot more than build tool. And WWW is just a template that I created to create applications a lot simpler. So let's just do that. Actually, let's do that. And we'll just add the browser REPL to it. So we're going to create. Actually, now let's do it here. Okay, so now we have an app. Well, no, let's create. If you want to make a little more money with this app, we probably want to do something like this. Right? Maybe. All right. And do you guys see the function? I probably should make it bigger, right? Is that good? Okay. So and I have. So let's go into the tab and see what's there. So that's basically what your app is. Now let's see where the REPL. Okay. Well, 1 second. I have my little cheat sheet. Sorry. Oh, okay, it's right here. It's with BREPL. With BREPL, okay. All right. Yeah, I was looking for this file. It was missing, so there's something else. You don't need to understand everything. This is just a template of the application. It's pretty simple. You have your static resources and some Clojure script files where you think about it as a JavaScript, and some endpoints where you can just start writing logic or routes or something like that. Again, this is totally voluntarily. This is how I like it. The way you create app, you can do just len new app, right? And you will be good. But since I use this www template, it just creates a template for me. So there's nothing real difficult here. So now let's just go in and start the REPL. So you start in the REPL, by typing len REPL, right? Compiling the Clojure script. We have some primitive Clojure script. The first compilation usually takes 5, 6, 7 seconds. The subsequent compilation will take 0 point something seconds. Okay, so now we have a REPL, and the first thing we'll do, we'll connect to the browser. So now we have. Okay, so let's. So right now we started the browser and we connected to the browser. So something that we can do, we can see that this, for example, 1 second, right? So this is a div with the ID container. So let's see if we can work with this div from the actual REPL, right? So we can take this. I can show you the syntax first. Okay, we'll come back to it. Okay, hold on. Right, so another thing I want to show you before that is that how dependencies are structured, right? So dependencies are usually located in this project.clojure, which is something like pom.xml, and they're very simply kind of packed into dependencies, right? So we're just going to add one dependency, which is a dummy library, which allows you to work with DOM. So that's how you do it. Imagine that we went to the pom.xml and added a dependency. So now as we started the REPL, that's why it gave me the error when I started to include a lot of stuff, because it didn't have this dependency. Okay, so connect to the browser again. Okay. Make sure we're still good. Okay, and now we can try to use my cheat sheet. Okay, so now this is the arbitrary name. I can name it C, but I just decided to name it with the $sign. So whoever uses jQuery, maybe it's gonna be a good name for it. So basically, we would just access it as we would in JavaScript, right? We'd say # container, which is an ID, right? So we have an ID here, right? So we just access it as # container, and we have the HTML div element, right? Again, we're using Clojure. Don't get confused by the syntax. It's actually not as hard as once you get around the Clojure itself. But this is basically as your imports in Java, as you would do import this, import that in Java. And now we can set it to something else. So let's see it live. So we have an I'm ready to be created here. And now let's set something else. So I'm ready and being created, right? So we basically have access to DOM elements from the Clojure script REPL, but we're using Clojure to do that. And I know maybe for people who do not use Clojure, it doesn't sound intuitive, and why would I do that? I know JavaScript, I'll better use JavaScript, but when you work with the Clojure code, it makes it a lot simpler to reason about the data structures. Another thing that all the power of Clojure, like functional stuff, is available to you, because JavaScript is functional language, but it has a lot of quirks that in Clojure script kind of makes it a lot softer. So besides, let me make this bigger as well. I think I jumped ahead a little. I wanted to show you I promised to show the data structures, and I didn't. So if you look at the data structures that we talked about, these guys, right? So we're gonna just try them, so you can get accustomed with them. All right. So let's define it. That's how you define stuff. You use def. Somebody uses Scala, maybe we're familiar. Basically, we defined a map, and we call it an M right here. So M is now a map, right? We can actually look at its type. The underlying implementation is something that's called persistent hash map, and we'll talk about persistent a little later. But this is basically this map is also immutable. You can see that there's also this weird things with the column, like A and B, A and Q, and these are called keywords. Keywords are also functions as well, so you can do something like this. Maps are also functions, so you can do something like this, right? So there are many ways how you can access the value in the map. The Java way would be something like this, right? That's the real Java way. It'll give you the same thing. But so basically that's the map. The vector would be the same thing, right? You just define a vector, and now it's a vector. V. It's persistent vector. We'll talk about what persistent means in a moment, but basically it's a vector of different types, right? You can see that this is a string because it's dynamically typed, and this is a value. Same thing for the set, right? You can say a hash set. What do we have there? And the set is a hash set, so you can, of course, not have duplicates there. If you define something with duplicates, right, it'll complain. It's very Java-like because Java is underneath, right? So JVM, it's the same behavior as you would expect. And you have a list. List is basically as it's a linked list. If a vector is something like array list is something like a linked list. Usually in Clojure you would use it to read the code and to generate the code because it's very efficient to prepend or append from different ends, but it's not efficient for random access, right? So usually in Clojure you would use vector. Vector is mostly used. And the function that we looked at, so we have a and b, right? And we just do a plus b. So it's a function, right? It's useless right now because it returns as a reference to the function. What can we do with it? We cannot do anything with it. So we can either call it like this. Nobody does that. I mean, some people do, but I mean that's not really pretty, right? So you would probably want to name it. The way you name it is you say def n, and you say sum, for example, right? And now you can use it as this, as such. Well, maybe not. What did I do wrong? Oh, that's right. Okay, cool. Yeah, thank you. Right, so that's pretty much all the syntax initial syntax that will allow you to understand what's going to happen later on the slides and all that. Do you have any questions about this for now? Is that too fast, too slow? Is that good? Good pace? Sure. Right, so that's a good question. So you're asking about cell1, right? So let's look at it a little in more detail. So we have a cell1, right, that returns to def. So cell is basically, that's not going to give you because it's a different REPL, but basically cell is from a dummy library. Cell1, probably better use Chrome for that. It's a function from a library, basically, that allows you to access. I don't have internet, unfortunately. Well, so the naming in Clojure is you can name it whatever you want. So some people use stars, for example, to actually from both ends to say that this is private. I mean, there's a way to define private things within the code. That's some kind of naming convention. You don't have to do it. Some people use question mark. For example, let me show you this. Maybe it'll be more. So you can, let's say you have like even 1, 2, 3, 4, 5, 6. So let's say we need to filter all the even numbers, right? So this is you know how in Java we have a name convention to have it is something, right? That returns a boolean, like is is valid or something like that, right? So, but the reason is it would be a lot better if we have something like this. If we can say, if, like, let's say let's pretend it's Java, if valid or something, I don't know, do this, right? Then it would read more natural, right? So but you can name your functions with whatever you want. So this is one of the examples why a symbol would be better. The reason they use in that particular library, the reason they use cell1 is because they also have cell where you can access more cells. So they say that they talk about DOM element as cells. And they just have a row, they have a cell. This particular library has this kind of function. It's not something that Clojure needs to do, or.
I mean, it's not common naming convention to use indices to indicate different.
Right. This is not a common thing for you, but it's a common thing for those guys who created the library, right? So it's really I respect that. I would not name it maybe if I wrote it, but this is just a library that I decided to show. There's actually many other libraries. There's a JQ library. If I had the internet, I would show you. But in JQ library, you would actually access it like this. Container, right? So they have a function named $, right? And then it's a little more natural to access things like that. Okay, right. Cool. Okay, let's move on. Oh yeah, there's something else I wanted to show you. I've been to the talk of Sergei Kursenko, where he showed Fibonacci with streamers. I don't know how many of you guys saw the Fibonacci stuff with stream APIs. Right, I just want to show you something similar in Clojure. I didn't have that planned, I just saw it, so I decided to kind of show it. So let's define a Fibonacci function, and I'll kind of explain what it is. So basically, that's exactly the way he defined it, but takes a little less code, as you can see. So it's a function, right, that takes two numbers and returns a number and the sum of those two numbers, right? So since we use this iterate, the same thing that he used, it'll basically keep returning us forever, right? It's lazy and it doesn't have any stop, so it'll return us every two numbers as many times as we're going to ask, right? So we cannot really call the Fibonacci number like this because it's going to hang. Let's say Fibonacci llama like this, right? Well, yeah. Well, you cannot call it because it's lazy, but let's say you could. We need to code on something like this. So we can take, for example, first. Let's take first 10 Fibonacci's, right? So we can say, yes, I know you infinite, I know you lazy, but try to go until you get to the 10th element. Right? This is a take while function that Sergei was implementing, right? Another interesting thing, I mean, you need a sum of it, right? So in Clojure, it's pretty simple, right? You just reduce and give it a sum. It's the same kind of idea that Java streamers have, with pretty much the same naming, but since the functional language has it built in, naturally, it's a lot simpler. And if you want to take a bigger number, let's say, I forgot what the number he was taking. So see what happens. There's an integer overflow, right? Because Clojure numbers primarily work with longs. If you want to work with big integers, you can, right? You can do something like this. But this is, and it's pretty fast. You can also go parallel as well. You can say, I think I have pfib, right? You can define. So I'm using parallel map here, the p map. There are other ways you can do it, but basically something interesting to see how simple it is to do. A couple lines of code to do something that in Java takes a little more lines of code. I'm not claiming that this is better. I'm just claiming that it's a little easier to reason about what you do when you can see everything and play with it in REPL. That's. I'm just gonna take this point away. Okay, just something to demonstrate. What else do I want to show? Okay, we did. Okay, so let's look at the composure, which is let's go to the web part of the talk. Okay, so let's get out of here. Let's go to, I think it's in handler, right? Okay, so this basically, I know the font is too big, but this is it, right? This is the whole web app. This is the whole web that we looked at, right? Remember this, I'm ready to be created here somewhere, right here. So this is the web app. It does a lot. It doesn't do anything, but basically this is it, right? So we imported some stuff, right? We imported some libraries right here. Think about it as import this, import this, import this, and now we defined some routes. Well, we defined one route, right? So we defined a route. So anybody who goes here, right, with these parameters, and we don't have any parameters, say I'm ready to be created. Say is actually, I think it's a function I defined somewhere. Yeah. Okay. So just basically, it's something like this. So it's say just serves this HTML to, well, maybe that doesn't look like HTML, but it is. It says it serves this HTML to the browser. Basically, that's all this route does. So let's create a different route. All right. Unfortunately, it doesn't fit on the screen, but let's pretend it does. Let's do this. Okay. So let's say we would like a route where we say, you won so many dollars, and the route will be 1, and that's the parameter. There's many ways how you can pass parameters. This is a get parameter. It's pretty simple, but one of the ways you can do it like this, right? Just in this particular library, you do it like this. In some other libraries, you may do it somewhere else. If you in a different way, if it doesn't satisfy your parameter wants and needs, you can write your own. It's pretty simple. But let's see how it works. So this works, right? And let's see this many dollars, not found, great. Why is not found? Okay, because I didn't compile it. Okay, so this is very primitive stuff. If you guys are web developers, so you know how to develop web. There's nothing hard here. But this is basically how you define your routes. It's very simple. If you did like Spring MVC or something like that, it's like you would define your controller and you would put those annotations, right? You get params and all the request stuff, all the HTTP. You can do with stuff with the HTTP session here as well. But it is simple, and it is something that you can immediately start doing stuff with, right? And again, this is just the Clojure library. There are many more. You can use some other libraries as well. So let's move on further. So we're on time. Let's come back to that later. I wanted to, well, let's do it anyway. Let's say we want to create an app that guesses, that let's see, that thinks of a number between 1 and 100, right? And then you need to guess it by entering stuff into the input field. How about that web app? A little more complex, right? Not too complex, but let's see what it does. So we just added a route that explains you what the all right. So the app will be doing this. It will be thinking of a number, right, between 1 and 0. It's a very kind of silly game, and then you need to guess it. So we probably need to add some input fields and something like that, right? So we'll go here in HTML that we had, and we probably need to change it in some way to kind of render different things, because right now that's the only thing that gets rendered, right? We need to render something else. So to do that, we'll go to. So if you look at it, this is another library that basically takes data structures and serves HTML, right? So you can see that P is a paragraph, div is div, input is input, and so forth. It's pretty simple, but ID content, or the content, P rules content. Should have forgot. Okay. Let's say that's it. And I think we're missing body. Okay. Actually, maybe not. I actually forgot if I need this div or not, but we'll see. All right, so we basically added, a paragraph with content, and then we will see what the hint is all about, and this is the input field where we're gonna enter our guess, and the button if we need to, a button to guess it. So let's see if it works. All right, so we can do something, right? It doesn't do anything yet because there's no actions, but we just added the route, and we added some HTML, right? So now let's add some actions to it. Don't be afraid, this is not that intense. Basically think about it as a JavaScript, but not. Oh, it's a Clojure. Okay. Oh, another thing is I forgot to show you. So this is a Clojure script, right? This is your JavaScript, and you can see that it actually works with this info would just do the console login. So it's a little test that allows you to see that this actually works. But we don't need this for now, so we'll just use this. Okay, the screen is a little small, so it's a little. Don't look at this. This is just imports. So let's look at what we do very quickly, and because we don't have a lot of time. So we define an answer, and an answer would be some random integer, between 1. The reason we have inc here is because the random integer will do 0 to 99, so we just increment it by 1, and the answer would be something, something that the program will come up with, and then we will display that answer in console. Let's do this. Okay. No. Okay. So we'll display that answer in the console, and then we define some things like enter key, and that's your cell 1 that you were asking about, basically to get the field, and the meat of this is basically the whole program. Unfortunately, the screen is too little. Maybe I don't know. It doesn't matter. Okay, so it's actually a lot better formatted, but it didn't fit here. But that's basically the meat of it. The whole application is 28 lines long, and that's the meat of it, right? So we get a number that you entered, and we say if it's less than a guess, we say that it needs to be greater. If it's greater than a guess, it did an answer, so it needs to be less, and so forth. And if it is an answer, then you won. How many? You won $1 million. Okay, so let's see if we have something. Okay. So what I'm doing here is I started a Clojure script compiler that will incrementally recompile it every time I change it. Okay. Okay, so now you can see, I don't know if you can see this, no, it doesn't change this, but it guessed the number 15, and it told us that it guessed the number 15, but we're not web developers, so we don't know, right? But it's easier for us to kind of go and see what it says. So let's say we guess 10, nothing greater, 20, nothing less, and then 15, boom, and it doesn't work, right? So it tells only numbers are allowed. Let's look at the logic again. Can anybody tell me why do you think it doesn't work? That's right. So that's right. So what? It is a string. So what? It is a string, and we compare numbers. That's right. So it's not less, it's not greater, right? As a string comparison, it definitely it doesn't equal because it's a string. So what do we do? Oh, okay. Well, we'll need to convert it, right? We need to convert it to. It's very simple. I mean, you guys as web developers know it for sure. So let's convert it. And we use, and the reason I'm showing it is because that's how you would. Clojure is a hosted language, right? In JVM, it's Java. With JVM, there it hosted in JavaScript, it's JavaScript environment where Clojure is hosted. So, and you can always call, functions from Java, or in this case JVM. Oh, sorry, from Java, or in this case JavaScript, to access, JavaScript EUA. And the reason I could do it with Clojure script, but I just decided to show you how you can access JavaScript. There is a parse int function that is JavaScript function. And that's how you do it, right? It's very simple. You just basically let, it's your local scoping. Let in Clojure allows you to define certain things, and then you can use those things within that local scope. And let's see if it works now. It's recompiled, right? It took 0.2575 seconds. And now let's see what we have now. Okay, so now the number is 7. Let's check it still works. It works, and now let's do 7, and whoa, we won $1 million. Actually, you did, right? No, actually, you can split it with the guy that asked us to convert it to integer. But it's very good, so it means somebody follows. Okay, so now let's move on to the slides. If I find them, should find them. No slides, okay. Really? Okay. All right. Woohoo, we're in business. Okay, sorry about that. So we are here. So I don't know what. Interesting. Okay, so it's interesting. Okay. You're not supposed to see that, so pretend it's not there. So now as we did some demo part, I don't know why it doesn't. Let's talk about core async a little bit. Let's see if it breaks, I don't know why. Okay, it doesn't matter. So we'll do this. So the core async is something that I mentioned before, is something that Clojure stole from language Go. And the idea is to reason about concurrency sequentially, and you'll see the example of that. And of course, this talk is not about core async. It requires a whole lot of talk, and I'll give you the reference to a very good talk about core async. So first, let's see a tiny little difference. In Go, we use Go routines and channels, and Clojure use Go macro, right, and channels. But basically, the idea is the same. It both follow the CSP principle, which is communicating sequential processes. Something that you can probably look in a wiki and to get a better idea. But I'll give you a hint of what it is a little bit. Okay. So let's say let's look at the blocking I/O for a moment. So this is, let's say you have 4 workers, and the arrow goes up. It goes out to, let's say, to get something from network, or something where the thread will block and wait for response, right? And then it'll get a response, and it'll continue doing what it's doing. It'll block again. So that's how the blocking I/O will look like. And you have 4 workers, right? In a core async way or a Go way, that's how you would package it, right? You would say, okay, the thread went out to get something from network. It's okay. Let's park it, right? Something that they call park. So let's put it in some kind of state machine, and let's give the real thread more work. The real thread does more work. Something needs to be done again with the I/O. Thread gets parked. The actual execution gets parked. Thread doesn't get parked. The actual execution gets parked, and then more work is given to the thread. So you can package that behavior that you see in 4 threads above in 2 threads below. This is just a visual. It doesn't need to be you don't have a gain in 2 or anything. This is just a visual for you to kind of a little bit understanding what it does without me going inside the CSP subject, which you can probably read on, and we'll see an example of this. So the reason I'm talking about it at all is because I want to show you how it's used in UI, and I don't have a lot of time, so I'll try to be a little faster. And but why do you need it in UI, right? Who cares? The JavaScript is single-threaded, right? You don't really care how many threads you have. So you only have one loop that that goes there and that does everything. That's true, but since since we still need to do a lot of concurrent work in the browser, we need to be right now we're doing with the callbacks and something that's called a callback hell and all that. But it's actually a lot better to reason about concurrency sequentially, and core async allows us to do that. So let's see. Let's look at this, for example. This is an application that I built out just to show you the difference. Let's say you have a search box. You enter something in the search box, and then you have Yahoo, Google, and Bing competing. Who's going to get your result first, right? So, and in this case, Google got it first, and I know you cannot see that, unfortunately, but maybe you can like this. I don't know. No, you can't. Okay, so, but Google won with 569 millisecond response time, right? Or if none of them wins within a certain timeout, you'd like to see that as well. So how would you implement it in JavaScript? Callbacks, okay. Right, but I mean, this is a trivial problem with a non-very trivial solution in JavaScript, right? So, but with core async, what you can do, and unfortunately I don't have time to go into more examples. I don't know why it doesn't show it right. Can you guys read that or no? Okay, cool. So that's pretty much all the code that's needed to implement that behavior. We set up something that's called a timeout channel. A timeout channel, think about it as something that will return null, or in Clojure terminology nil, in a certain amount of time, right? So think about that channel. Then we have we're doing 3 asynchronous gets And this alt, if you guys are familiar with the network programming, for example, how many of you are familiar with Netty framework? Okay, so it doesn't have to be Netty, but if you're familiar with the non-blocking I/O approach to, or Node.js or ePol stuff, so the way it works, it basically calls select on a socket, right? And then gives it an option. For example, I call select on a socket, and I care about reading the socket, right? And then it reads the socket when it takes, and it's in a loop. When it sees the first thing coming from the socket, I'm talking about the network low-level stuff, it dispatches it to the worker, right? That's how Netty, for example, works, or ePol solution Node.js, and that's how it works. And then you have a single thread, one thread, that dispatches the work to workers, and the only thing it does, it selects. It's a mutex select on the socket. That alt thing it does the same thing. So basically you have 4 inputs, like think about it like 4 sockets, right? And whoever gets there first, it takes the execution and then it dispatches the worker. And the workers are here. In our case, we'll just declare the winner, or we'll show the timeout. Let's say I don't have a lot of time, so I'll take the questions later. But just remember. I don't know if you buy into that principle or not, but you cannot argue that this is not sequential, right? This is a very callbacky stuff in JavaScript, but you can reason about it sequentially as this. And the idea, again, not to explain you how core async works, but just to excite you so you can read more, and maybe if it interests you, maybe you can look at it later. Again, the JavaScript tells us that there are many ways to manage callback hell. That's true. But core async tells us what is a callback hell, right? Doesn't know what it is. And again, this is a different talk. This is a very good talk by the guy who actually wrote, one of the guys who wrote core async. You can read about it later. So now let's jump into OM. And I don't think I have enough time to go through all the OM, but we'll go through however much time I have. So OM says, let's take all the MVC that we know and love and simplify it to V. So what they do, they have this concept of components, and they put view and they put the view and the logic within the component, right? And that component is something that can be unit tested well, is something that can be shared with others. It's something that has different life cycle, and we'll kind of look at it in a little bit. So it's based on Facebook React. It's not the OM's idea. It's Facebook. It's actually Instagram guys' idea. They created the React.js, and since Facebook is now in Instagram, is the same thing. We say it's a Facebook idea. And OM adds immutability, and we'll see why it's important. The interesting analogy to what React.js or OM is how many of you guys know how Doom engine works, like Doom 3 especially? You know what Doom is, right? Okay, cool. So let's say I tell you that I'm an expert how Doom works, which I'm not, but I'll pretend. So that's how Doom works, right? So you have a game input state for all the different user events, all the where everybody is, and so there's some input stuff, right? The game event state. It goes into the game logic. That's where the whole what needs to be done happens. Okay, this guy is here, this guy has this weapon, I go to this and this place, what do I do? And what the game logic does, it generates the intermediate representation of a scene. So it says, okay, so he went forward and lifted up his weapon. So what would the game look like now? Right, this little delta from before is sent to this rendering OpenGL. Well, let's say it's sent to the scene intermediate representation kind of block. So now he was like this, he was like this, and now he's this, right? So that's all that's sent into that block. Then it goes to the renderer, the OpenGL renderer, and says for this to show that this happens, that's the operations you need to do. You need to move his leg here, you need to change the color or whatever. And the OpenGL operations get flushed into the graphic cards, right? I know it might sound a little confusing, but basically the idea is that the basic idea here is that you don't look at the game as a whole and try to change everything. Is you look at the little events, right, in the game, and then you generate deltas right? Of how this particular thing changed. Then you go and generate OpenGL operations and you flush it to the graphic cards. So now let's see how React.js works in this case, right? It's exactly the same way. And Doom actually is proven to be, very, very performant in terms of how it uses the GPUs, how it uses the graphics. So it's something that, even though it breaks MVC, it's something that's really, interesting to look at. It's something that's worthwhile to look at. And so we have an application state, right? And then application state generates different kind of events, right? User events, again, different kind of events. And we have this React components that I talked about. So React components is where the logic is. So if I get, this event, how should I change my state, right? And they have something that they call a virtual DOM, which if you, so let's say they need to put this delta in a real DOM, in a real JavaScript DOM, the browser will hang in 2 seconds, because DOM is not something, robust and flexible that you can pound with a lot of changes. So what they did, they created a virtual DOM, and they change it in their virtual DOM in memory, and then they compute those deltas and then flush it to the browser. And I'm sorry, I'm Russian. I probably don't have enough time, right? So okay. So if I can, I'll show you some code. If I cannot, then you'll believe me that it works. Okay. So this is a very good talk. So idea here was not to tell you how it works. Was not to tell you exactly what's underneath. You can go to this guy. This is the guy who leads it and who wrote most of it. But this is not Om guy. This is the React.js guy. But the concepts are all the same. This is a very good talk, and he explains it. And the Doom stuff is something I stole from him, right? Not something I came up with myself. It's a lot easier to steal stuff. That's what smart people do. Okay. So now I want to go through. So I wanted to show you something, a live code, but let's move on a little bit, and I'll come back if I have another 2 minutes. I'll come back and show you the code. And then the way you would create it is something like this. You would create an app, and you just add with Om. Again, this is a template that I wrote. There are many ways to create it. If you Google how to create it, it will show you many different ways to create it. Okay. So the cool thing that Om adds is immutability, right? And why? So there are two cool things that kind of the consequences of it. So first is, remember how I was talking about these deltas? So React, in order for React to figure out the delta between this object and this object, it needs to do some kind of deep comparison, right? It cannot do reference comparison because something inside can change. But since in Clojure everything is immutable, remember those maps and vectors and all that I showed you, everything is immutable. So Clojure saves a lot of time because from the deep comparison, it becomes reference comparison. Is this reference the same? If the reference is not the same, something changed, that's all. So it becomes a lot faster, and there are a lot of blog articles where they show you the difference. Difference in performance is huge. Another thing they do, there are some other things they do to boost the performance, but this is pretty cool. The reason I talk about time travel is because if the only thing that needs to be changed in React or Om application, the only thing that you change to re-render stuff is a state. You don't deal with the re-rendering stuff yourself. You don't deal with all the JavaScript. You just say, okay, it was milk now. I had to buy milk. Now I bought milk. So you change that string and it re-renders, right? So if we are immutable, if Clojure data structures are immutable, we can remember those things and pile them up in the history, right? And then it would be very trivial for us to undo each operations and to re-render state of the past, right? And that's exactly what I wanted to show you. Because in JavaScript, you cannot rely on that state to be immutable. If you did it in JavaScript, you have to guard that state. You have to make sure that nobody changes it. In ClojureScript, it's not possible to change it. So it's always going to be the same. So you just put it, let's say you put it in a list. Let's say this is the current state of my web application. Let me put it in the list. This is another current state of my application over the next iteration. Let me put it in the list. You would think it's very very expensive, right? How can you put 10,000 states in the list? It's probably going to blow up. But Clojure uses something that's called persistent data structures, and I'm coming back to the persistent hash map, persistent set, persistent that you saw from live coding, right? And the idea is very powerful and very simple. Basically, you do structural sharing, right? Let's say you need to create a new structure that will need to share this previous structure. You do not add those elements. You just create a new reference and change it in a way so it becomes a different data structure, right? this is, again, this is something to look into. I'm not saying that this is, I'm not saying that I explain it well, but this is something that you can look into. You can go online. Persistent data structures, by the way, is something that Scala stole from Clojure. So all the Scala data structures, all the Scala collections are persistent data structures. And I think Rich Hickey, the guy who wrote Clojure, he took the concept from Phil Bagwell, who wrote hash array map trie. So he based it on hash array map trie, which is a very shallow tree with a factor of 32, and it's very simple to get to the elements in the tree. But again, since I don't have time, I'm not going to go into it. But it's called persistent data structures, and it's a very interesting topic. Just go and read more about it if you're interested. And that's how you can basically pile up the history, right? So because you don't pile up browser state 100%, browser state 100%. You only pile up differences using these persistent data structures. And let me see if I can quickly show you the app. It's going to be quick, okay? I apologize that I went a little over time. So let me go into some to-do list that I wrote. To do in repo. Okay, so we're going to look at the. Is it? Oh, okay. So we're going to look at the very simple application. I think this is 40 lines of code. It's a GNOME application, and it's basically what it does. It's a to-do list. This is it. That's the list we're going to look at. You can see it's a map with a key to-dos and a list of to-dos. In the beginning of the app, it's empty. So let's look at it. Oh. Yay. Oh, we didn't connect to the browser. Sorry. Okay. Actually, it looks better in Chrome, so let's do Chrome instead. Okay, so the idea is if I need to buy milk, right? You go read about persistent data structures, right? Some else, blah. Right, so you can add those things into your list. So right now this list has 4 things, right? And we can, I mean, you can say it's done. You can say whatever, but that's not very interesting. What's interesting is that you can let's see if we can, how easy it is to remember all this and then go back, like travel back in time. And just to save time, I have this little expert. To-do list component, to-do component. And I'm sorry about the formatting, because it should be formatted, should be a lot prettier. And then we need this, just the button to actually undo stuff. Okay. So now it's 1, 2, 3, 4. We can, oh, there's no undo button, okay. 1, 2, 3, 4. We can actually do 5 if you thought we couldn't. Now we can do, this is done, this is done, this is done. Or I will do different things. And now look, now we can do undo, and it actually goes back and re-renders all the things. And let's look at how it's possible. That's going to be the last 20 seconds. So don't worry. All right. So what did we do here? Okay. Where's the undo stuff? Okay. So that's it. Oh, I couldn't find it because it's not formatted properly. Okay, so that's the undo. We're saying basically what it says is when the app history is something that it's that list, right? It's that data structure that we put the application state, and we say if it's one, or if it's more than one, right? If we have something in the history, then we pop it from the history, right? We don't need that anymore. We don't need the current state, and we basically reset the state to something that was lost in the history. So we don't re-render, we don't do any, we don't analyze the dump tree, we don't do anything. We just work with the state. We say we have something in the history, yes we do, okay, put it in the list. I'm sorry, to take it out of the history and reset the current application state to that thing that we got from the history. And with that, I'll open the room for questions and answers if we have any time. If we don't, then thank you very much.